You open your eyes and find yourself in a white room. Moments ago, you were in a car crash. You see the twisted metal of the car, the blood leaking from your wounds. You remember the pain, the darkness. You died. And yet here you are, alive, breathing. What if I told you this isn't a miracle, but science? The theory's so strange, it suggests you can be killed 1,000,000,000 times and still never truly die. We all have an enemy that lurks within our bodies. As we grow older, its power grows with us. We call it entropy. It's the reason our bodies break down. It's the reason we age. It's also the reason why we die. But what if I told you this enemy could be turned against itself? What if we could discover a way to kill the thing that kills us? This is a special episode of C-Show in Minute Earth. You are staring at the center of a massive explosion. You feel the heat of thousands of suns. You're inside a star when it goes supernova. The light from the explosion gives birth to elements heavier than iron, the building blocks of new stars and planets and people. As you watch, those elements condense into a new solar system and you think, wow, I'm immortal. There are many ways we might achieve immortality. We may defeat death by becoming like a star and converting ourselves into a new form, or we might battle entropy more directly by overcoming the breakdown of our cells and reversing the aging process. We might even cheat death by uploading our consciousness into a computer. Some of these ideas seem more plausible than others, but none of them are impossible. So which one will work first? Who knows? But while humanity pursues each of these paths, scientists are studying an even weirder question. What if we could kill death itself? To understand this question, we need to learn about black holes. Black holes are regions in space where gravity is so strong nothing can escape their grasp, not even light. They are defined by their event horizon, the boundary of no return. Once something crosses the event horizon, it can never come back out again. Black holes have a reputation for being terrifying cosmic beasts, but they are really just objects with really strong gravity. Like any object, they have a mass, and the more massive an object is, the stronger its gravity. That means some black holes have very strong gravity and others don't. In fact, gravity isn't even that strong around most black holes. Only a small number of black holes have gravity that's strong enough to trap light. What makes a black hole is not so much its gravity as its size. If an object has a mass big enough to squeeze through the size of a proton, it will become a black hole no matter how slowly you approach that size. But the tiniest possible black hole would be unimaginably dense. It's good we haven't found any mini black holes, because if anyone ever did find one, they would want to do an experiment. They would want to throw stuff into the black hole to see how quickly it disappeared. When you toss an object toward a black hole, its gravity starts tugging on the object. If the object is heavy enough, the gravity will eventually overpower everything else, keeping the object together, including nuclear forces. Gravity will literally tear the object apart. Objects falling into a black hole get torn apart in this way all the time. Astronomers call this process spaghettification, due to the shape it gives the object. Basically, you get stretched out like spaghetti, and that raises a question. If we kept making a black hole smaller and smaller, how small could we make it before the gravity was strong enough to tear apart anything that fell in, including theoretically us? If we wanted to fall into a black hole and never come back out, how small would the black hole have to be? This is where things get weird. Even though miniaturized black holes would have extremely strong gravity, they would have another problem. The sheer density of the black hole means there's an awful lot of gravity concentrated in a teeny space, and that means that if we get too close to the black hole, we'll experience all that gravity at once. At a certain point, the force of gravity would start ripping apart atoms. Eventually, it would rip apart elementary particles. And at some point, we would encounter a particle that had a negative gravitational charge. Since we've never discovered such particles, we can only speculate about what they would be like. But if they exist, they should obey the same rules as other particles. They should have a mass, which means they have gravity, and they should have a gravitational field. This means if we got close enough to a sufficiently tiny black hole, its gravity would start pushing us away. It would be repelled by the negatively charged particles inside us. At some point, these repulsive forces would become so strong that they would overcome the inward pull of the black hole as gravity. At that point, we would stop falling toward the black hole and instead would start flying away from it. In fact, we'd be flung away so fast that we would travel faster than the speed of light. And now we've killed death. Well, not technically. The reason we'd be traveling faster than light is that we'd be traveling backward in time. The black hole would fling us back to the past. We'd be moving backward relative to the universe, which would mean we would be moving forward in our own lives. All the damage done to our body by the black hole's gravity would be undone, and we'd be returned to life. In other words, we would be made immortal. Okay, we're not actually making ourselves immortal. That would take infinite energy. Instead, we're killing the particular version of ourselves that happens to be alive right now. If we could somehow recycle our own dead cells, we could keep making new versions of ourselves forever. It's like Thanos from Marvel Comics collecting the Infinity Stones. Every time he snapped his fingers, half of all life in the universe vanished. But he was bringing back previous versions of people who had already died, giving them a chance at a new life. If we could replicate that process, we would be killing every current version of ourselves, but creating copies of our former selves in the process. It's like we're playing a game of cosmic dodge death. Each time death comes for us, we kill off the current version of ourselves. But in doing so, we make room for a new version of ourselves to live. Theoretically, we could keep this up forever, making new versions of ourselves out of the remains of old ones. We would be stuck in a sort of time loop, constantly dying, but never really dying. And it turns out that this game of cosmic dodge death doesn't require a black hole at all. It only requires a machine that can harness the power of a black hole, and scientists say such machines are possible. If we could build a device called a traversable wormhole, we could send copies of ourselves back in time and kill previous versions of ourselves. We would have to destroy those copies of ourselves as quickly as we created them, but we could potentially use the same machine to send new copies of ourselves back in time and keep the cycle going. Now, scientists don't expect that wormholes will ever be built. Not only are they hypothetical, but even if they were possible, they would be incredibly dangerous. But the idea illustrates how our understanding of the universe is forcing us to rethink the nature of death. Death is inevitable unless we can find a way to cheat it, conquer it, or kill it. There are many ways we might achieve immortality, but none of them are easy. We may defeat death by becoming like a star and converting ourselves into a new form, or we might battle entropy more directly by overcoming the breakdown of our cells and reversing the aging process. We might even cheat death by uploading our consciousness into a computer. Some of these ideas seem more plausible than others, but none of them are impossible. So which one will work first? Who knows? But while humanity pursues each of these paths, scientists are studying even weirder questions. What if we could kill death itself? Thank you for watching this special SCI Show and Minute Earth episode.